So let me move this out of the way. Um, Go ahead and get this underway. Today we're going to be covering a lot of content as it relates to how you take an application, an old application, and move it into a container environment to take care of some of the hard work of modernizing apps. But before I get into this, I just wanted to introduce myself. My name is Blaze Stewart. I'm a senior consultant at Wintellect, and I'm on Twitter at the One Mule and online at blaze.net. You can reach out to me on either venue, and if you have questions, even after this is over. And we're also available for consulting and so on for container work as well. A little bit about Wintellect, if you're not familiar with who we are. Wintellect is a consulting and training company that we do two lines of business in training. One is on-demand training, and that's through our website, Wintellect Now. And another one is through instructor-led training, which is where you can either have an online course or we can bring an instructor on site. And we also do consulting on a number of technologies, including Docker. And Docker is one of my specialties, and we also do Xamarin and other things as it relates to Azure and DevOps and so on. You might have heard of us. Some of our folks are industry respected experts. Jeff Procyse, John Robbins, Jeffrey Richter have all written many books. You probably have some of these on your shelf if you've been doing .NET development for any length of time. Particularly Jeffrey Richter's CLR via C Sharp, or even going back to the old MFC days with Jeff Procyse's book on Windows MFC. But let's segue into what we're going to be talking about today, and that's actually containers themselves. As you are familiar with containers, I hope you are, because I don't have a whole lot of time to really explain what a container is, but I will briefly touch on this. It's a container is like a virtual machine, and that is a virtualization technology. The biggest difference, though, is it doesn't abstract hardware like a virtual machine does. It actually abstracts an operating system. So you'll notice down here on this particular uh, stack here, you have a hypervisor and it loads a guest operating system and libraries and then your apps on top of that. Over here, you have the container engine, then you have libraries running on top of the container engine, and then apps running on top of the libraries. Note these two blocks here would represent a container. This would be a container, and this would be a container. Notice that there's no guest operating system here. That's because the container engine is providing an abstraction of the underlying operating system. So it could be Windows or Linux or what have you. While in a virtual machine, you have to install a guest operating system on top of a host operating system. So it's slightly smaller than what you'd give with a virtual machine, but the fundamental difference is just the layer of abstraction. Containers, it's at the operating system level, and virtual machines, it's at the hardware level. And that has implications downstream because you get better density with containers, but it also means that containers are married essentially to the underlying operating system in which they're running. So only Linux containers can run on a Linux host and Windows containers on a Windows host. So that's one of the limitations of containers. It's just one of the trade-offs you get for better density on the host. And one of the main drivers behind containers is DevOps. And this would be another big driver for doing modernization for applications, particularly legacy applications, is the ability to use DevOps pipelines for legacy applications. Now, it is possible to do this other ways, but one of the big selling points of containers is that it gives you the ability to use not only modern methodologies for deploying applications, but it allows you to use your old applications or your legacy applications in those same DevOps pipelines that you would otherwise be using for your more current applications that might be written on microservices or some other new technology that old legacy applications weren't written on. I'm not going to go into deep dive into that, but it's just to let you know that containers and DevOps go hand in glove, and it is one of the major motivators for actually doing containerization. So with that aside, what are some of the other motivations you might want to use for app modernization? You might want to take advantage of some more recent technology patterns, you might want to move to the cloud. Containers are a popular way of hosting applications in the cloud. So it could be Azure, it could be AWS. Both of them have the ability to put things on the cloud as containers in many different ways. You're wanting to improve operational efficiency. Again, you want to deploy those DevOps pipelines in order to operationalize an application that used to be more manual to do, and it required a lot more time and human intervention. Otherwise, you can automate that through operate and with DevOps and get better operational efficiency. Also, you also can use one might want to use it to was a way to, as I mentioned, to unify new and old apps, or use the same tools for both deploying your new apps and your old apps. And mostly, you might want to save money and save time. That is one of the biggest motivators for doing any kind of app modernization, is to get off your big iron servers and go to something that is going to be a lot more lean and ultimately save you a lot of time and money in the long run. So that's our biggest driver behind all these things that we've already mentioned up to this point. But with any application, your motivation might not be one of those. You might have a completely different reason, but these are some of the main reasons that people might want to go to app modernization, particularly with containers. So to modernize an application, there is essentially I want to say a five-step process. These aren't necessarily discrete steps that you would go through, and you might go back and forth between these, and it might even be a cycle that you go through. But the overview of what we're going to be talking about in this webinar today is these five steps on how to modernize an application. Um, in, and we're going to do that by breaking this complex task down into five steps, and then we're going to break these five steps down into some sub steps that we can look at, and how we can actually go through the work of doing everything we need to do to get to the point where we actually migrate an app to container, if that be the case. So the first one that we want to talk about is identify dependencies, and I'm going to define that, what I mean by that when I say identify dependencies. Now, with dependencies, what we're talking about is we're talking about not talking about like inter-application dependencies, not dependencies that are baked into the code per se. We're talking about dependencies in the environment. So there's a lot of things that might be dependencies that you might have for an application, such as a database. That's a dependency. Your application must have a database to run. So that's the kind of database dependency I'm talking about. Operating system requirements. So I need Windows. I need Linux. I need a particular version of Linux. I need a particular version of Windows, or I need BSD, or I need something like that to run my application. Application frameworks. I need something like Java. I need a particular version of Java. I need PHP, I need Node.js, I need .NET, I need .NET Core, and so on. You have these application frameworks that are dependencies for your application to run on. Some other ones might be special libraries. So you have a special PDF library that generates something that you need in order to send your customer a receipt, or some special library that you need to do some kind of email notification system, or something like that. These special libraries I would exclude as separate dependencies from your application framework, although they might be supported by your framework. And the reason why you'd want to do that is just to make sure that you're um, accounting for those, something that's not going to be included out of the box with something like PHP. You need a PHP module, for instance, or you need something that's just not baked into that application framework. Storage requirements, storage dependencies. So some applications don't have storage dependencies, others do. I need a place to store some kind of files that get uploaded to my server. I need some kind of storage for configuration files. I don't know. There might be some hard dependency on some kind of storage device that you have, and so on. Networking requirements. I have certain constraints on ports that my application uses on TCP/IP or something like that. And then some other ones might be web services or network remote procedure calls. And these are anything that that wouldn't be necessarily hosted on the server that's running your application. They might be something that's hosted in the cloud or elsewhere on premise that you might need to consider as a dependency for your application to run. So these are things you have to consider whenever you're building out the dependencies. And lastly, specific hardware. Say your application requires hardware tokens, sensors. Maybe it's an application that's collecting data from cameras, or in the event that you had a hardware token that you were using to sign applications with, or you're signing some kind of code with or something like that, you needed that to be plugged into some USB port on the machine, and that specific hardware that's needed for that application to run. So all of these are some kind of dependency that you have that is needed for your application. You may have one or more or none of these if in the case of some maybe some lighter applications. But the point is that you want to be able to identify what these dependencies are, and that's very important when you start thinking about containers, and we'll talk about the reason why we're going to do that later on. The next thing that you want to do is make a dependency map, and I'm going to show you an example of this in just a minute. But a dependency map is where you just take all those dependencies that you listed out and you essentially draw boxes on a diagram. You say SQL Server or database server or something like that as it currently exists. So that way you show the connection between all the pieces that are inside of your application. You want to show the ones that are both logical connections, like something that's more like an application functionality. So the library that, for instance, that's supporting your application would be a logical dependency, not something that's necessarily a physical dependency, which would be something else like how is the data or functionality provided. So a logical dependency would be something like a database. The physically that is provided by way of a network connection or something like that. Now you don't have to write all that out in gross detail. The basic purpose of doing a dependency map is so you understand how all of these other dependencies that we just talked about relate to one another, which were all the databases and networking and storage and so on. Now, the next thing to do is determine if there are hard or soft dependencies. Now, what I mean by that is hard dependencies being like specific versions of an OS versus just something else, like a soft dependency would be it just needs Windows, for instance. So a hard dependency, I need Windows 2000 Server 2003 for this to run. I need Windows 64-bit for this to run. I need some hard dependency that is a very specific version of an operating system, a specific version of a database, some kind of specific host name for something to work, or a specific database. Maybe for some reason somebody hard coded that into the application and it's necessary to run. So these are, when I say hard dependencies, what I'm really talking about here is those that are just non-negotiable. In other words, I have no room for fudging these at all. I can't change these. These are just necessary, absolutely necessary dependencies for my application to run. Now, a soft dependency, when in this case, what I'm talking about more or less is the um, a, a dependency that isn't necessarily tied to a specific version or implementation of something. Like say, I need SQL Server. Well, in some instances, if I was moving something to the cloud, for instance, I can use something like Azure SQL to stand in the place of a traditional SQL Server, and it fulfills all those requirements that SQL Server did. But that's just my application will work on Azure SQL or it'll work on a local instance of SQL Server installed, or it can run on a SQL Server container or it needs file storage or something like that. Now, um, we'll work through some of the dependencies, well, I'll show you examples of these as I work through an example of this, which I think is going to bring me to my case study. My case study is, I'm going to use this as a running demo or running discussion through this just to show you kind of what I'm talking about um, when I'm talking about these 5 steps to modernizing an application. So let's say for this instance, I have an e-commerce website and I used it to sell products online. It's a custom website, so it's completely custom and I don't have the time or resources to rewrite the application. It's got all the business rules for my business baked into that application, and I can't just go out and buy something off the shelf that will fulfill it. So in order to make it work, I would have to either A, modernize it in some other way, shape, form, or fashion, or rewrite the application. But I don't have the time or resource to do that. My environment is a classic ASP app that's running on Server 2008 R2 with IIS with SQL Server 2005. And all of these are running on the same server. So I have SQL Server 2005 installed on 2008 R2 along with IIS and classic ASP and my application. So it's a single server. So it's a fairly small um, install. So I'm a small business. I'm running a website, an e-commerce site that I sell things on. And what's prompted me to do this is I have collated this in a data center. Then the server itself is aging. So you can kind of gauge based on the fact that it's running server R2 that this was running on, say, 10-year-old hardware. And the hardware issues have prompted me to consider moving this to a new environment. So I'm at a junction here where I need to get it off this old hardware. I need to move it into something that is more modern, more secure. That's going to be more that's got a longer term life than Server R 2008 R2 and SQL Server 2005, both of which are coming towards the end of their life. Actually, Classic ASP is too, but I can't afford to go back and rewrite it. So that's my constraints. That's my case study, and this is what I'm going to be working from in the this presentation today. So what would my dependency map look like? So based on that information I just gave you, it might look like something like this. I have an e-commerce website. And it's basic. It's running classic ASP as the framework. That's my application framework, and I have static content. Notice that these are in red. And the reason I put these in red is because these are going to be my hard dependencies, as I just mentioned. These I cannot change the fact that this application, short of rewriting it, I cannot change the fact that this is running on classic ASP. So that is a hard dependency I have for this application. I cannot change the static content. I need that. That's all the images and CSS and JavaScript that are a part of this. So I can't change that. So these are my hard dependencies. The negotiable components of this would be these down here in yellow. For instance, IIS. If I could make this run on some other server, it's not particular. It didn't have to be IIS. As far as I know, the only thing that really runs Classic ASP would be IIS, but it doesn't have to be a specific version of IIS. So I can run this on IIS 6, 7, 8, all the way up to the most recent versions that are installed in Server 2016. It uses the MSSQL ODBC driver. It's not tied to a particular version of that, so I'm pretty at will to use whatever version I want as long as I can invoke that driver from Classic ASP. Then I should be okay. It's not tied to a particular version of SQL Server. It's not tied to a particular version of Windows. So these are all up for negotiation as to which one I use. So this is my dependency map, and I wanted to show you this so that you can see I have hard dependencies here, and I have the software dependencies down here, and I used a cloud to denote that these are connected by way of a network. So that I'm actually using a local host if they're on the same server. I could use name pipes or something like that for SQL Server, but I'm using the network connected to back to SQL Server 2005 from the MS SQL ODBC library. So I have a network connection here that works well for moving data back and forth there, and that's going to be to my advantage later on, and we'll see why whenever we start going through some of the next steps in this process. So the next step in this process is to isolate application components. So we've already talked about dependencies and we've seen the dependency map. And the reason I want you to see the dependency map is because when we isolate components, what we're really trying to do is figure out what components on that dependency map can I spin off and create something that's a standalone environment for a particular component. So the one thing that should be applied religiously to containers is the single responsibility principle. And in software development, this is the idea that any particular software component should do one thing and one thing only. It should never do more than that. You don't want to bake a lot of functionality into a single method or into a single a class and so on. And the same thing applies to containers. When you start thinking about containers, you want to design your container architecture in such a way that you only really want to include the most minimal amount of functionality in a given container for a given application. Now, that's not always possible depending on the nature of the application and the constraints of the application, but you want to apply that to the degree possible. So in our case, we're going to have to, we're going to, I will show you what we're going to do in the next step on how we actually flesh these containers out. But we want to apply that principle to the degree possible whenever we start talking about containers. Next, you want to isolate any components or dependencies in the application that can be run independently, such as a database server. And we're going to be looking at how to do a database server, for instance. That's one of my you can see where I'm going with this with the SQL Server 2005. I could think about, oh, I can put that into its own container or something like that. And isolating components that are just not always possible legacy applications, which tend to be more monolithic. So you might want to look for layers in your application that can be abstracted away if that's possible. In some legacy applications, like some in-tier applications, you might have a UI layer and a business layer, and the UI layer talks to the business layer underneath by way of web services, and they're using the HTTP protocol. Well, you can separate those layers independent of one another, and they can exist in separate environments. Um, and you don't have to have them on the same physical server or even in the same instance of Windows for them to work. So in that case, you could put layers there. However, you couldn't isolate it like you would a microservice, which a microservice you can isolate the services themselves in that business layer from one another. So you have a layer of services that are all independently deployed rather than just a single layer where all the services are running. So again, you can still do something like a microservice with a service layer, but you can't break it down to the fullest degree that you would a microservice. But in any case, you're trying to look for those layers that you can run independently, or those components that you can run independently, and then use the dependency map to show these isolations. So these isolations will likely to become containers. So going back to my dependency map here, what I have here is I've drawn this dotted line. These are possible options for isolating components. See, I have static content over here. I could potentially isolate that if I wanted to. I could, spin that off, and the static content could take on a life of its own. Say I put a load balancer in front of this, and anything that had that static content goes to one web server, and anything that's classic ASP goes to another web server. So all those requests could be routed based on the kind of content they are, or something to that extent. I mean, I'm just thinking out loud here, but this one in the top right here and kind of in the middle, this is all necessary to run together because I can't separate classic ASP from the ODBC driver, IIS, or Windows. So that would be one level of isolation. And then I have the SQL Server down here. I could isolate that to the degree possible with SQL Server 2005 running on a Windows server as well. So these are some possible isolations that I could in this application create. So moving on to the next step is to determine if the container fits. So when I talk about container fit there's several factors that we have to discuss when we talk about if a container is a good option for actually deploying applications into. Just because you can put something in a container doesn't mean you ought to put something in a container. Now, isolating application components is the first step to try to understand if something can go into a container to determine if it fits. So there's some criterion you can look at to actually evaluate this. Containers are not a silver bullet. They won't solve all your problems. I guarantee you there are use cases for containers that will not fit for containers, and we're going to look at how you decide when and when not to use containers. So here's some factors that we want to look at whenever we talk about containers. You want to talk about scope, size, and the service model that you're going to be using. Now, when I talk about scope, I'm talking about is the application implicitly or explicitly tied to an environment, or is it more agnostic to the environment? For instance, if I have a driver, an app, I have a driver that is tied to a piece of hardware, then that is not environment agnostic. That is tied to the hardware that it's running. The driver itself is pretty useless without the hardware that it's running. Or if I have some kind of application that requires cameras, like I was talking about it earlier, the application itself is pretty useless without those cameras. So it's not going to, it's implicitly tied to the environment. So something like a web app, though, is not necessarily tied to the environment. That's something that I can take from one server to the next, or I can take out of my environment entirely and put it into the cloud, for instance. Now, there might be something in that web app that does tie it to the environment. There's some kind of process I cannot remove from my environment that I cannot move to the cloud. And in that case, that's just something that I have to consider. Doesn't mean I can't use containers. It means just I just have to figure out how to provide the kind of connectivity for that implicit or explicit dependency that I might have inside of the scope of my application. The next thing is to consider size. Now, size it means that can I run my application alongside other applications? In other words, can I share compute resources such as memory, CPU, and so on? If an application requires a scope that is significantly larger than what I have inside of my environment, say I need multiple machines to run it, that's not a good idea with containers because you're not going to see any benefits of using containers. That means you basically have one container running on one VM or one physical machine, and that's not really a good use of containers. Containers are intended to give you high density of applications on the same compute hardware, so it's a shared environment. So I can have multiple containers running on a single environment. So if the size is such that I can run it alongside multiple other applications, then it's probably a good fit for containers. And lastly, the service model. Can the application's deployment and maintenance be automated, or does it require manual intervention? Now, what I'm talking about here is the whole idea of DevOps and CI/CD. You know, if an application requires that I babysit it all the time and I have to go in and manually tweak things all the time, then that's a service model is very manual. Doesn't mean I can't use containers. It just means that it's going to make deploying it in containers a little bit more difficult than what you would otherwise be able to do if through fully automated DevOps pipelines. So if you had to put something like this on a on a chart, I'm going to show you a graph here in a minute. It would look, you would want something to be small in size, you want it to be environment agnostic, and you want it to be have a highly automated service model. And this is what makes containers more ideal. These are the kind of applications that lend themselves much more towards containers than something that doesn't fit these. But don't let that be a showstopper. Just because it's not ideal doesn't mean it can't be containerized. It just means it's more challenging to do so. So to look at a chart, you might think of it like this. If I had on one axis, I had a service model between traditional manual deployments and automated deployments on one axis. That would be my y-axis. And then my x-axis, I have size. On one extreme, I have microservices. On the other extreme, I have multi-machine clusters. Then what I'm going to be looking for is high automation and something that lends itself to small size. So it's going to kind of isolate it up there towards that top right quadrant. And that's going to be more ideal for containers, while virtual machines and other applications would be that lower left quadrant and maybe even that upper left quadrant to some degree. So just because something's not automatable and something's not small in size doesn't mean it won't fit in a container. Just realize that there are challenges that are associated with that, and that's just something that you have to plan for whenever you think about deploying containers. So when you have decided that containers are a good fit for your application, then you can start um, planning out your migration strategy. But go back to my case study here. Um, SQL Server is a hefty requirement relative to an existing server. However, my database is small for my instance. So SQL Server 2005 on old hardware was usually required almost a fully dedicated machine to run it, unless it was a smaller instance. In my case, it's just a small database, and so there's less overhead and more compute available. So in this case, I probably could Dockerize this instance of SQL Server, and Microsoft has made SQL Server available in a Docker image that's a general purpose and can be used. So I would rate this as it is it is environment agnostic because it's just a database. It's a medium size and it is highly automatable because I can automate the deployment of the SQL Server by way of a Docker container and also deploy the database in that as well. And then my classic ASP website requires IIS and Windows to run. This requires Windows Core Container with IIS and Classic ASP installed and configured to support the application. Classic ASP is relatively nimble. Now, the heavy requirement here is Windows. Windows core containers are not lightweight, so I would rate this as a medium size, and it's a highly automatable process, and I would say it's a fairly agnostic to the environment that I'm actually running in. It's a website, so I can deploy this, virtually anywhere I can deploy websites. So I just have to take into account that I have two medium. My size is both medium in both cases, but it's highly automatable. So my constraints here are really going to be dealing with the size of the containers I'm going to be deploying. So I have to kind of factor that into any kind of costing that I might consider, or the kind of container environment that I might be using to host these in, because both of these would ultimately be server core containers based on the fact that it'd be a SQL Server container and a Windows container, which are not small by any stretch of the imagination. So yes, it will work. I just have that caveat that is not that the size is going to be a challenge whenever I start dealing with this stuff. So the next thing to do is plan your migration. So this is where you take your components, you take your dependency map, and you map on to containers onto those layers in isolation. Once you've decided that, okay, I think I can make this stuff work in containers, you want to figure out what's going to be the best way to containerize these applications, and then also uh, using the dependency map mark their isolations. Not all areas will require containers. For instance, in some cases, it might make more sense to migrate something to a PaaS solution and then use a container connected to the PaaS solution. So, for instance, if I wanted to take this website to the cloud, I could move my SQL Server database into SQL Server, Azure SQL, and then host my container on, say, Azure Container Instances or something like that, and have a single container hitting a PaaS solution for the database. That would work. That might be a possible migration path as well. Um, and in other cases, container environments provide supporting functionality for data. For instance, I might use Docker volumes um, for static content or for database storage. And in other cases, when planning a migration, it's also a good time to think about upgrading components to newer, more secure supported components, which I'm doing here. I'm actually moving things off of SQL Server 2005, off of SQL 2008 R2 to something more modern, Server Core for that matter. And then devs are going to receive more updates. They're going to receive more timely updates, and they're going to be more secure environment overall for deploying my application. And also, when you're planning a migration, don't just think about the one-step process of lift and shift this application. You also want a plan of how you're going to maintain this application downstream. Remember what we said earlier, one of the biggest motivations for modernizing applications is DevOps. You want to be able to operationalize this stuff with automation involved. So you want to plan for how you will maintain the applications with automation tools. So whatever that may be that you're using for DevOps, it could be that you're using something as simple as just the command line in Docker to manage a small instance of a website, or this is part of a larger suite of other applications, and you want to use something that's a lot more robust than that. Then that would be something like VSTS, Jenkins, or something like that that you're using to manage that DevOps pipeline as well. So the point is that you want to really think through not just the lift and shift aspect of this, the migration of this. It's also how am I going to in the future maintain this application? How am I going to push out updates to this application? And what tooling am I going to use to do that with? And so that's important to consider whenever you're planning a migration. And then this is also where familiarity with Docker is going to really come in handy. And if you're unsure, read up on Docker or solicit help from those who do. When you think about one of the biggest traps that people fall into when they start thinking about containers is to think of them as an analog or a replacement for virtual machines. Like I said earlier, they're not full replacements for virtual machines. They do a lot of the same kinds of things that virtual machines can do, but again, it doesn't mean that these are full replacements for virtual machines. In fact, you want to think about them differently. So you want to get familiar with best practices on containers. You want to be well aware of what is what makes a good container environment, what doesn't. And we've talked about some of that already. as it relates to deploying things into single responsibility principle, and so on when we talk about familiarity with containers best practices. So read up on that, and then or solicit the help from somebody who already knows that. Have them take a look at your your dependency diagram, and then say, hey, what could I do possibly to as a migration strategy for my website? So with that in mind, I going back to my case study here, this is what I think might work for my application. I'm thinking I'm going to have two containers to run this environment here. I have this SQL Server database here down here. It's running SQL 2017 inside of a container on server core, and then I have another container over here running um, server core, and I'm running IIS, and I install classic ASP on that, my MS SQL ODBC driver, and then I put my static content. Now, like I said earlier, it would be possible if I had a load balancer in front of this, I could do content-based routing based on is it static content, and farm out another container to just do nothing but SQL, do nothing but static content. But in this case, Docker provides a clean way of doing this with Docker volume, so I can put all my static content on a Docker volume, and it really becomes overkill at that point, really, to have a separate container to just do that. So I just said, well, we can use the same container for the static content and mount that as a volume as I would to run my classic ASP application. Now, there are some cases where you might not want to do this and for performance reasons. For instance, like with PHP applications, um, using PHP FPM, for instance, is a fantastic case where you would, as almost a textbook example, where you want to have your runtime environment for your as a separate container, because PHP FPM, if you're not familiar with that, is a process manager for PHP applications. So what that does is it lets the process management of that be farmed off to something else other than the web server, which could be Nginx, Apache, or something else entirely for managing those processes. So in the case of PHP, what I typically do for a PHP application is I have all the static content in one container, hosted by one container in a Docker volume. Then I have all the PHP execution happen in a separate container and let PHP FPM manage those processes, because you get big performance boosts on that if you do. So for performance reasons, I would do it differently in that case. But in this instance, I'm not going to get any kind of advantage out of that. So I think a two container configuration is probably going to be reasonable here. So you have to think through not only the technology stack that you're dealing with, what's going to be the best case scenario for that, but also what's going to be the best bet for what I'm trying to do, in the constraints I do have with whatever I'm dealing with. So, and the last thing to do is actually to migrate the application. Now, this is where now you probably got to this point by going through the process of identifying dependencies, isolating components, determining if the containers fit, planning the migration. And this is where you actually get down in the weeds and you start to actually do things like build Docker files and script out the deployment of this. You build the images and you push those to a repository, and then you deploy the images to a test, and finally deploy those to a new environment, and you perform a switchover. So this process is a very typical, Docker type migration, where you build your Docker container, build your Docker images, push them to a repository, test them, and so on and so forth, and then you perform a switchover. So this, I don't think I have it listed here, is you would also want to consider moving this not from just a simple manual process, but in the process of building out the Docker files and so on, you want to consider what it would take to put this stuff into your DevOps pipelines and CI/CD pipelines, which are probably going to start with Docker files and so on at the bare minimum, and then as you mature in the process of migrating this application, you're going to probably think about, well, how am I going to script this out with VSTS, or how am I going to script this out with Jenkins or something like that, to deploy those Docker files, to create the images, push them to repositories, and deploy those to test environments, and put those into my QA and UAT, and finally into production, and so on. So whatever your migration strategy is for your application, you do need to think more than just Docker files. You need to think about CI/CD as well, which is one of those things. And maybe it's not that you're not thinking about it. Maybe it's just that you don't care. But I would encourage you to think through that as well, especially if it's an enterprise application. So I do want to look at a demo here. I'm going to apologize in advance. I had my demo all up and working, and my machine uh, just went kaput, for lack of better words, and so my demo for some reason isn't working in its entirety now. So I'm going to apologize in advance, but I do want to show you what I did have working, and then show you what I did to get there, and maybe by some grace of the demo gods it will work. But in any case, let me get out a PowerPoint. Um, and show you what I am trying to migrate here. So here's my server. This is my website. It's just a simple e-commerce website. It's running on um, Windows Server 2008 R2 in a virtual machine here. And just to show you that, I think I can pull up, system, and this will tell me what I'm running here. I think this is a 64-bit Windows Server 2008 R2. I have SQL Server 2005 installed on this virtual machine as well, and I'm running this on Hyper-V. So this is a full-blown virtual machine. It's fairly small, modest hardware. Just so for the sake of demo here, I just pretend this is the environment that I want to migrate. So this is the machine that I'm having problems with in my data center. So I want to move this into containers. So to do that, I have to migrate not only my database, but I have to migrate my application as well. Now, to migrate my database, um, what I did is I can probably pull up localhost here and look at, see what I have going on here inside of this database. So my database is just a simple database with just tables. Fortunately, with this database, I didn't really have much in terms of store procedures or any of that. So I have just there's really no store procedures. There's no functions. There's none of that stuff. So migrating this between environments would actually be fairly straightforward. There's nothing special about these tables. They're just pretty much generic data tables. Nothing going on like that. So this is a really good candidate for moving from SQL 2005. You can actually move it all the way to SQL 2017 in one step without going through any iterative steps. So, and that's exactly what I did. So what I did to migrate this database is I created another container and a container database, and then used the data migration assistant from Microsoft that's designed to move databases from SQL Server into Azure SQL, but it also allows you to move from SQL Server to another SQL Server instance as well. And so I was able to use that tool. You could also use the import export tool that comes with SQL Server Management Studio to do that with. Now, again, this is not restricted to SQL Server. You can do this with any set of tooling that you might have. It could be um, MySQL, it could be Oracle, it could be any of those tooling. You just figure out, well, how would you go about doing that with the tooling that you have? How do I get the database out of my server environment, or out of my legacy environment, if you have a database or what have you, into my next environment? And that's the upgrade path I was taking here, was from SQL 2005 to SQL Server 2017 in a Docker container. And this part I do have working to show you what I did here. Here's my same database. This is actually running on if I go Docker inspect, and I show you SQL-server. I'm going to pull up the IP address right here. Notice 172.23.138.99, and I've connected not that SQL Server Management Studio here to that same IP address. And so here's my database running on a Docker container, and here's all my tables. So I just did a data migration. It's the exact same, just pretty much a lift and shift from SQL Server 2005 into this Docker container running SQL Server. So that was very straightforward and very easy to do. So I didn't have to do a whole lot of work here for that. That was fairly straightforward. Now my demo that I was going to show you was actually to run this website. this website that I have running here inside the container. However, for whatever reason, whenever I went to deploy this, start this back up, it wasn't working. So Docker ps-a to show you, I had this one called my shop here, and Docker inspect my dash shop. Um, there's the IP address of my uh, Docker container actually running my containerized version of this website. Now, I don't have, I had to go figure out what's going on. See, it's giving me an error when I try to access it right now. I do know it's working under the hood. It's probably some kind of connectivity to the database or something like that. I'm not 100% sure what's going on. I haven't had the time to troubleshoot this when I started this back up about 30 minutes before this webinar. But in any case, what would happen if this, in the perfect world where demos go perfect every time, would be that I get this website running inside the Docker container. And I did have it, just have to take my word for it. I did have it working. But I do want to show you the Docker file because the Docker file is the magic that makes it all happen. The Docker file here is using Microsoft IIS, and the Docker file is the script that basically builds the container images that you would want to use to deploy into your repository. So with this one, what I did is I went out and I looked up how do I enable a classic ASP on IIS using PowerShell. And by way of using PowerShell, I don't, because I'm using a container, I don't have a GUI. I can't go in there and tweak the GUI. I wanted to automate this too, so that I can build this out using a script rather than having to do this manually every time I want to do something. I figured out how to install all the components that I needed to set up, classic ASP inside of my application. I'm sorry, inside of IIS on side of a server core container. And these were the steps to do that. And I'll put this code out on GitHub or something like that for someone to download if you so choose, and link this when we publish this video. But this is the steps that was needed to make it work. And once it was working, I did take the um, I did take I did have the ability to go to that website, that URL, and punch it in and see my website up and running. So that is what I did. Now, sorry again, it's not working. Maybe if I rebuild it, I go Docker stop my shop and rebuild this container, I might be able to actually um, uh, redeploy this and it might work. I don't know. I've had bad luck with this today, so no promises here, but we'll see how that goes. So let's let that build and see what happens after I redeploy it. So going back to the slide deck, I just to recap what we've talked about. We talked about what we need to do to actually do this. Uh, we need to identify the dependencies. We need to isolate the application components. We need to determine if the container is a fit, plan the migration, then finally migrate the application. Now, again, these 5 steps are not necessarily you don't necessarily have to complete these one at a time, or have it all the way have all your dependencies identified before you move on to step 2 and step 3. Sometimes you might be getting into the weeds on planning your migration and you realize that you forgot another dependency, so you have to go back up to step 1 and then include that into your dependency map, and then go on to step 2, think about that again through isolating the component, and then move on. Does the container fit for that newly discovered dependency? Or maybe you get into the migration phase of the application and you discover that there's something about the application that just doesn't work well, and you need to rethink the migration plan um, whenever you start going through the process of mapping containers onto the isolated components and so on. So the reality of this is basically is, if you don't hear me say anything else, it's to get down in the weeds on the dependencies, because that's really where it's all going to come down to, is figuring out what those dependencies are, and then how can I isolate those dependencies to migrate those into multiple containers, to as many containers as I can possibly do, because you want to isolate those to the most granular level that you can possibly do inside of containers to get the best performance for those containers. So if you don't hear me say anything else, focus on dependencies, and the rest of this kind of precipitates out of that, if you will. So Just to wrap up, if you want to follow me on Twitter, you can go out there to the One Mule. You can go out to Wintellect and sign up for training if you want. We have training on containerization of applications or Docker in general, or .NET and Docker. We have some training on that. We also have Wintellect Now videos for that. And then also let us help you migrate your apps. If you have questions related to that, we have consulting services available, and we will gladly work with you on evaluating your application and then working through that process that I just went through and to get your application and containerize it, and even more so help you deploy that to cloud if you want to go that route, or if you want to deploy Docker on premise in your own data center, we can help you do that as well. So we have a lot of possible avenues if you want to solicit us for help as well. So let me go back and check on my build here from Docker, and let's see if I'm gonna maybe if I deploy this one more time, and maybe it'll like me. Um, rm-f my-shop, and just see if this works. Cross our fingers, maybe it will. Um, and it's created. One thing about Windows core containers is they are large and they do take a while to create and spin up. So this one's taking, a Linux container would be up and running by now in most cases. No, okay, it's up now. Okay, we're up for 1 second. So let me do a Docker inspect. I mean, maybe I got lucky this time, and get the IP for this. And then if this doesn't work, then I'll take some questions and we can go from there. So we can go my-shop, and there's an IP address. I'm gonna grab that because that's the IP address I need to use to pull up this website. And let's see what happens. Yeah, it's not working again. So in any case, I can start answering questions to see if we guys have some here. And gladly help you out here. Okay. All right. So I have about 10 or so questions here. So let's see. Let's just start from the top and go from there. Let me pull this up right here, and then so if you want to go out there, look at my Twitter feed and so on, um, to wrap up. How containers enable hot deployment, no downtime. There's multiple ways to do that with containers. What typically you want to do, you want to build HA clusters and then really consider versioning as a build. You want to bake versioning into your containers, and then you want to be able to deploy new versions of your containers alongside of the old versions, and then do switchovers. So it's basically rolling upgrades. You want to, and also with containers, it all also comes down to really how your application is architected. This is why you want to, like, to the degree possible, especially if you're developing new applications, is to develop them as granular as possible. So you want to be able to make sure that your modules are as there's just few modules running in any single container at a time. That way it makes upgrading any single component of your application independent of the other one. So if I need to upgrade SQL Server, for instance, I can uh, create another instance of SQL Server, swap the database over to another instance, and then take down patch it, and then do a swap over, and then I have virtually no downtime that way. So that's what you want to do there. It's basically just architect things in such a way where you have high availability, and then if you version them in such a way that you can swap things out with zero downtime. And you also want to be able to do that by way of using something like load balancers and things like that, so that you can um, redirect traffic based on upgrade cycles and things like that. So, is there something that containers for clients examples, Java runtime, Silverlight Flash, Crystal reports, and client access? Containers are more server-side technology. So, to that question, I would say no. No, there's not. There's not containers for clients per se. Now, you can run applications in containers that are server-side that are written in Java or things like that. But most of the container is aimed squarely at server-side technology. And in some cases, there are some client-side stuff, but it's not stuff that you're going to be interacting with a GUI. So containers are really more for stuff that you run in a shell environment. I'm sorry, a command line environment or something like that, or something that's going to be running some kind of network daemon like a database or something along those lines. Um, can I recommend a tool for creating dependency map. Well, I used draw.io. So any credible tool for creating dependency map, because I was trying to just generically talk about this. Dependency mapping is an art, and so depending on your environment is really going to depend on what you use for creating dependency map. The biggest thing that is not so much creating dependency maps per se. I mean, that's you can use any modeling tool for that pretty much. PowerPoint would work for that. You could use Visio. Draw.io is another good tool, and it's basically just figuring out you know drawing boxes and lines and stuff on a page. So, but it's discovering what the dependencies are is really where the tough thing is. And in Windows, you have things like Dependency Walker, or you have Process Explorer, or tools like that that will tell you what you're running in your environment and tell you what DLLs you have and so on. And if you have access to source code, well, that's even better. You can go through the source code and figure out where your dependencies are as well. Um, Second, another question here. Why was there a before on the unlock statement? Oh, that's an escape sequence. That's a Docker thing. He's talking about in my Docker file here. This line here. This is to tell Docker to use the tick mark, the back tick for escape character versus the backslash or something like that. That's typically used in Windows Docker files. So that's why I have it there. Um, so yeah, that's to answer that question really quickly. Let's see what we have here. Let's go back to this slide. In your mapping container slide, number 22, what are the pros and cons to combine two containers into one containers? Like I was talking about earlier, is like the single responsibility principle is as applied to containers allows you to upgrade into containers independently more from one another. There's really no real advantages of putting everything into one container other than the fact that it's in one container. And some people might think that's easier to manage, but truth is, long term, that's actually harder to manage because you're liable to break something whenever you upgrade a single component of that, and so on. So really, what you want to do with that is to break out these components as to the degree possible for level of granularity. So the single responsibility principle applied to containers means that you want to isolate it to the degree possible. Can I share the presentation? Yes, this video will be published. You'll be able to watch this video. We'll put it up on our Wintellect Now YouTube channel, and you'll be able to watch it. Watch out for it on Wintellect webinars as well. We publish all this stuff here. Do you know of any published benchmarks or studies that compare the performance or overhead when migrating an app from a physical virtual machine to a container environment? Um, there is research. There's been a lot of research done on this. I can actually, the reality is it's only about 1 or 2% difference between a virtual machine and a container in terms of what you take in terms of performance hit. So if I have all things being equal, if I have a virtual machine running an application or if I have a container running the same application on the same environment, the container is going to be about 1 or 2% slower. However, that doesn't, I mean, that's like 1 or 2%. But the trade-off there is I don't have to maintain a full virtual machine. I just have to maintain the container. So I've got less maintenance and less overhead when it comes to memory, disk space, and CPU because I don't have to run additional operating systems per application. So yes, there are benchmarks. There are studies that compare performance and so on. Just run a quick Google search on that. I don't have any right off the top of my head. I have read some white papers on that. Um, so yes, definitely look that up though. Um, let's see. And the last question is, no one in the middle. Let's see. No in the middle line right before the word unlock. Oh, unlock my Docker file. I'm not sure what you're talking about here. Um, unlock. Um, Here again, that's the escape sequence there. That's this right here um, is just a escape character. So he says the line after that. This one right here, unlock config. That's a quote mark. It might be a bug or something like that. I might be the reason that my thing is failing too. Um, okay. But in any case, Docker for Windows and Nano Server and Core feel inadequate for an application that actually spins up a Windows and graphically measured items. I know this because it's atypical server side, but this is our scenario. Um, I'm not sure what that's intended for. It's just a statement, okay. Um, and let's see if there's any more questions here. Okay. Well, if there's no more questions, then we'll call it a curious opinion about one last question. Curious about this. Um, the Docker Windows Nano Server and Core feel inadequate for an application that adequately spins up Windows and graphically measures the item. I know this is atypical for a server-side app, but this is our scenario. Are you talking about performance? I'm supposing that's the gist of the question there. Um, Docker for Windows doesn't actually spin up a full-blown version of Windows. It's actually running on the kernel that's hosting it. So it's more. I'm talking about support for things like GDI and graphics. No, you wouldn't run Core or Nano for any kind of graphics. That's not what they're intended for. In fact, they're meant to be run headless so that you don't need that. So you wouldn't ever run a graphics-based application inside of a Core or Nano server for any reason, or particularly a, uh, a Docker container for that matter, because there is no graphics layer there. Well, let's wrap this up, and we'll post this webinar, the recording, as soon as we get it wrapped up, and you can go back and watch this, and you can look at. I'm going to try to post uh, the slide of the code up there on GitHub, and I'll put a link to it as well. So it's been a pleasure. I hope you guys have a wonderful afternoon, and thank you for logging in. And I hope to see you next time on Docker. Sorry, on Wintellect webinars.